Binomial theorem. Question number 1. The value of 15C0 square minus 15C1 square plus 15C2 square minus 15C15 square each. Let's consider its solution. So first we expand 1 plus x power 15. From here we get 15C0 plus 15C1x plus 15C15 x power 15. Now we write 1 minus 1 upon x power 15. Expand it. So we get 15C0 minus 15C1 times 1 upon x plus minus 15C15 1 upon x power 15. Now we multiply these two expressions. So 1 plus x power 15 times 1 minus 1 upon x power 15 equal to 15C0 plus 15C1x plus plus minus 15C15 x power 15 multiplied by 15C0 minus 15C1 into 1 upon x plus Here, the first one should have been plus, and this is minus 15C15 x power 1 upon. Now, term independent of x in RHS. So when we multiply 15C0 to 15C0, we will get, here we write term independent of x in RHS. So it will be 15C0 whole square. But here x and 1 upon x will cancel out. From here we will get 15C1 whole square plus 15C2 whole square. And last term will be minus 15C15 whole square. Now consider LHS. So in LHS, we have 1 plus x power 15 multiplied by 1 minus 1 upon x power 15. From here, we can take common minus 1 upon x. So 1 plus x power 15 can be written as x upon x minus 1 upon x power 15. Then we can take common minus 1 upon x power 15. So we will be left with 1 plus x power 15 multiplied by 1 minus x power 15. Or equivalently 1 upon x power 15 times 1 minus x square power 15. Now term independent of x can be found if we get x power 15 in the expansion of 1 minus x square whole power 15. But if we expand it, every power of x will be multiple of 2. That can't be 15. Hence, we say that coefficient or term independent of x in LHS, term independent of x in LHS is 0. Hence, we can say that 15C0 square minus 15C1 square plus 15C2 square minus 15C15 square must be equal to 0. Now let's consider next question. Find the value of 2C0 2 squared by 2C1 plus 2 cubed by 3C2 plus till 2 power 11 by 11 C10. Here, this question can be solved by two methods. We are going to apply integration method. So let's consider the function 1 plus x power 10 and we expand it. So we get 10C0 plus 10C1 x plus 10C2 x square. The last term 10C10 x power 10. Now what we do? We integrate it. So on integration we will get 1 plus x power 11 divided by 11 plus c equal to 10C0x plus 10C1 x squared by 2 plus 10C2 x cubed by 3 plus 10C10 x power 11 by 11. Now we put the condition when x equal to 0. Then what is c? So we will get c equal to minus 1 by 11. So here we get 1 plus x power 11 divided by 11 minus 1 upon 11 equal to 10C0 x plus 10C1 x squared by 2 plus plus 10C10 x power 11 by 11. Now we put x equal to 2. What do we get? 1 plus 2 will become 3. So 3 power 11 minus 1 divided by 11 equal to 2 times 10C0 plus 2 squared by 2 10C1 plus plus 2 power 11 by 11 10C0, which is our answer. So 2C0 plus 2 squared by 2C1 etc. is equal to 3 power 11 minus 1 divided by 11. Now let's see next question. Question says find the value of C0 upon 1 plus C2 upon 3 plus C4 upon 5 etc. So there is one formula. Formula says C0 plus C2 plus C4 plus equal to C1 plus C3 plus equal to 2 power n minus 1. So we will make use of this formula, and also 2 power n is equal to 1 plus nc1 plus nc2 plus nc3 etc. Here nc3 or nc1 means just c1. Now let's consider the question C0 upon 1, C0 upon 1 plus C2 upon 3 plus C3, C4 upon 5 plus . We write the values 1 plus this will become n into n minus 1 divided by 3 times factorial 2 plus n into n minus 1, n minus 2, n minus 3 upon 5 times factorial 4 plus dot 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 dot. Now, if we multiply and divide by n plus 1, so 1 upon n plus 1, then n plus 1 plus n plus 1 n into n minus 1 upon factorial 3 plus n plus 1 times n minus 1 times n minus 2 times n minus 3 upon factorial 5 and so on. So this will become 1 upon n plus 1 times n plus 1 C1 plus n plus 1 C3 plus n plus 1 C5 plus dot 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 dot, which can be written as 1 upon n plus 1 times half of 2 power n plus 1, which can be further written as 2 power n divided by n plus 1, which is our answer. Now, let's consider next question. The sum of the coefficients in the expansion of 1 plus x minus 3x squared whole power 2163 is. So it is very simple question. Put x equal to 1. Then what do we get? 1 plus 1 minus 3 whole power 2163 minus 1 power 2163, which is minus 1. So sum of the coefficients in the expression like this is minus 1. And this can be obtained by putting x equal to 1. Now, let's see next question, question number 5. The coefficients of 2r plus 4th term and r minus 2th term in the expansion of 1 plus x power 18 are equal. Then what is r? So let's write general term dr plus 1 equal to ncr x power n minus r by r. So here we have to find out 2r plus 4th term. So we can write t 2r plus 3 plus 1 equal to n is in our expression 18 c 2r plus 3 and x is 1 and y is x. So x power 2r plus 3 and r minus 2th term. So t r minus 3 plus 1 will be 18 c r minus 3 x power r minus 3. But these two, the coefficients are equal. So let's equate them. So we equate 18 c 2r plus 3 is equal to 18 c r minus 3. Now here we can apply the formula NCR equal to NC n minus R. So 18 C 2R plus 3 equal to 18 C 18 minus R plus 3. So these two terms will be equal. So 2R plus 3 must be equal to 21 minus R. So 3R equal to 18, which will give R equal to 6. Which is our answer. Now, let's take one more question. The next question is, If x power minus 7 occurs in the rth term of ax minus b upon x squared power 11, then what is the value of r? So let's write general term tr will become tr minus 1 plus 1 equals n means 11 c r minus 1 and ax power 11 minus r minus 1. So plus 1 and then minus b upon x square power r minus 1. Now we further simplify. So 11c r minus 1 a power 12 minus r x power 12 minus r minus b power r minus 1 times x power minus 2 power r minus 1, which gives 11cr minus 1 a power 12 minus r minus b power r minus 1 x power 12 minus r minus 2r plus 2. So it will become 14 minus 3r. So here in our question, coefficient of x power minus 7. So 14 minus 3r is equal to minus 7. So we can say that 14 plus 7 equal to 3r, or r equal to 21 upon 3, that is 7. So which is our answer? Thank you.